Though he isn't the first kaiju placed on the silver screen, that honour going to King Kong, though whether you consider the 1933 King Kong movie as a kaiju movie is up for debate. But regardless, 1954 introduced us to Godzilla, who has appeared in over 38 films and TV shows that continue to be released this very day. There are a number of Godzilla continuities and origin stories, so we're going to focus in this lecture on the MonsterVerse version of Godzilla, which is these two here. This one from Godzilla Cross Kong, but you don't need to worry, no spoilers coming up, because this is a science video where we are going to look at the origins of Godzilla, some of the science of Godzilla, and why, unfortunately, we don't have giant lizards, apes, moths, robot dinosaurs, dinosaurs with 3 heads, sort of Hydra, a sort of pterodactyl looking thing. Why we don't have any of that roaming around on planet Earth. Welcome to Science After Hours. Before we discuss his physical origins, let's talk about the name Gojira or Godzilla. So the original Japanese name Gojira is said to be derived from the Japanese of gorilla and whale, and this represents the strength and the size of both of these animals. The English translation, Godzilla, continues in this tradition, keeping the gorilla part, introducing the lizard part, because Godzilla is indeed a giant reptile, also introducing God. God himself, is known for being all-powerful, the king of everything, and Godzilla is the king of the monsters. So he has that power, he has that strength from a gorilla, and he is a reptile from the lizard, Godzilla. In universe, he is given the title Titanus Gojira by the multinational scientific company Monarch, and he was first thought to be described by ancient humans on the Pacific Islands, which aren't shown here, where they found Monarch, that is, ancient temple carvings, which suggested that Godzilla was worshipped like a god. Godzilla and the other titans, for that matter. So Titanus Gojira is Godzilla, but for all intents and purposes, we'll just call him Godzilla from now on. So, Eiji Tsuruzawa, this fellow here, one of the founding members of Monarch, suggested that Godzilla arose from the late Permian period, which is this is it here, 255 million years ago, but the Permian period covers 299 to 251 million years ago. And Dr. Tsuruzawa here thought that Godzilla was one of the apex predators of this time. And him and the other titans were able to feed off of the geothermal radiation that was given out by the late Permian Earth, and that allowed them to roam free, feeding on whatever they needed to feed on. However, after a number of mass extinction events, these geothermic radiation levels dropped, and Godzilla and the other titans had to flee and go into sort of a period of hibernation. And this was possibly done in Hollow Earth, in the MonsterVerse universe. If you haven't seen them, the Earth is hollow. You've got the outer Earth where humans and stuff live, and then on the inside of the Earth is this whole other ecosystem filled with its own titans. So Kong lives there now, and it's thought that Godzilla and the other titans fled down there because the radiation levels were higher. They were able to rest and hibernate. Again, Monarch found ancient temples submerged within Hollow Earth that depicted carvings of Godzilla. This is King Ghidorah here, another titan. So you can imagine that they were, this is visual proof in the Monsterverse world that these titans existed long ago and were in the Hollow Earth. In the 1950s, so we're going to talk about 2014 in a minute, but in the 1950s, a nuclear submarine awakened Godzilla. This attracted him to the surface, and there was all these new sources of radiation that he could feed off. Nuclear power plants, nuclear bombs and bomb testing sites. So Godzilla continued to feed off both US and Soviet nuclear submarines, intensifying the Cold War as both sides were blaming each other for the loss of the craft, until in 1954 the US were able to lure Godzilla in the range of one of their first hydrogen bombs, and Godzilla disappeared. Thought never to be seen again, thought he was dead, but in 2014, due to some human meddling, these mutos, massive unidentified terrestrial organisms, a male and a female, were roaming the earth trying to find one another so they could mate. And Godzilla, he was having none of this. He comes out of hibernation, he's like, I've got to put a stop to these two mating. No sex on Godzilla's watch. Why, you might think, has Godzilla got such a problem with these two, seemingly extremely large and quite destructive organisms, but they're just, part of the natural world. Why would Godzilla have a problem with them? Well, it turns out that when mutos mate, they lay their eggs in the corpses of creatures that are Godzilla's species, allowing those eggs to feed off of the radiation held within Godzilla's body, and that's good for the egg and the baby and the muto species as a whole, but quite bad for Godzilla, especially when Godzilla is, unfortunately, the last of his kind. Godzilla swiftly dealt with the mutos and killed one of them, the female one, with what was then colloquially called his kiss of death, firing his atomic breath straight into the mouth of the female muto, destroying her. And that Godzilla, after 2014, is like, I've dealt with these mutos, I'm going back to the sea, I have no problems with humans, just leave me alone. But over the next decade, all sorts of issues arose, meaning Godzilla had to keep coming out of hibernation. So he ended up combating Rodan. We talked about Rodan in the periodic table video. There he is there. This is Rodan, in case you were wondering. This is again King Ghidorah. This at the back here is Mechagodzilla, because humans cannot just behave like normal rational people. Godzilla destroys all of these, and the reason it was determined by Monarch that Godzilla is very much like a Jedi. Godzilla's role in the natural world is to maintain a balance between the human world and the world of the Titans. And so he can do this from his position as king of the monsters. After slaying King Ghidorah here, the other Titans bow to Godzilla. They accept that he is the apex of all of them. Humans then get involved, make a Mechagodzilla. Godzilla's like, oh no. I'm the king round here. I'm maintaining the balance. Godzilla, with a bit of help from Kong, destroys Mechagodzilla. And again, he goes back into the sea to look out for other Titans and humans that get up to no good. And when they do get up to no good, Godzilla will put them in his place. Arguably, the coolest thing about Godzilla and what allows him to be the king of the monsters is how amazingly cool his atomic breath is. From what it looks like to the sound it makes, this atomic breath is arguably one of the most recognisable features of the character and has been present since that 1954 original film. So let us take a quick look at Godzilla's atomic breath. I was very fortunate and I was able to survive that Godzilla attack and bring you this lecture today where we can talk about some of Godzilla's anatomy. So here we have a cross section of Godzilla. Unfortunately it's written in Japanese, but I will point out the most important parts. So inside Godzilla is a bionuclear circulatory system, and this activates when he is threatened, allowing him to undergo that big charge up action that we saw in that previous clip. This triggers a neutron flux which manifests as that blue glow which builds up inside of his dorsal fins. Then these dorsal fins then act as an energy reserve, continuing to build up as the neutron flux gains more and more power until eventually it reaches its peak and arrives at the nucleosynthetic glands in Godzilla's throat, which allow this nuclear energy to be concentrated and explode out of his mouth in that atomic energy blast that we see. Sometimes this blast is blue, most not commonly, but in alternate variations of Godzilla, or if Godzilla has been supercharged in some way, this atomic breath could be a different colour. So in Godzilla Cross Kong, for instance, we get this evolved form of Godzilla. You may have seen him in the trailers where he has this pink tinge to him. I'm not going to tell you why, but importantly for this section, that has a large effect on his atomic breath. His atomic breath becomes more powerful, but it also changes in colour. It becomes pink to match the nuclear energy that he is producing. Sadly, we have no animals that we know of that can fire a beam of concentrated radiation from its mouth. And as mentioned at the start of this video, we don't have giant creatures walking the earth, destroying national landmarks, making the daily news cycle ever so more exciting, a slight break up from the horror stories of war and famine and capitalism issues. We have no giant titans. But back in the day, we used to have dinosaurs. Yes, the dinosaurs have gone extinct, but why don't we have large megafauna, as it's called, in 2024? Why didn't the dinosaurs, or something dinosaur-like, return after extinction? The obvious reason is, unsurprisingly, the human race, us. So this plot here from Vermeer's 2015 shows that in each prehistoric era, this is not all of the prehistoric eras, but in each of the prehistoric eras between the early, mid and the late, the number of megafauna species increased over time. Then there was a extinction event separating the eras, and the larger species were wiped out. But again, over time, the numbers build back up until the next mass extinction event, where they go down again, and then they continue back up. So it's been quite a while since the large mass extinction event, so I think we're talking asteroids hitting the Earth. Where are the dinosaurs? Where are our megafauna? Well, it is described now that we are actually in a mass extinction event, the Holocene mass extinction event. And unlike these mass extinction events, which occurred extremely quickly, asteroid hits Earth, mass extinction. This mass extinction event, the Holocene mass extinction event, is slow because it is us. We are changing the planet for ultimately our own gain. We are building cities, cutting down forests and whatnot. We are changing the biodiversity of the planet by hunting, by changing the makeup or the farming that we do. That takes away land mass for wild species. And this figure here, which is produced from data made in 1984, you can see the black arrow represents when Homo sapiens entered these particular continents. And this is the proportion of large mammal species. We're going to talk about mammals here, and we'll get to that in a minute as to why. But you can see that as soon as the human race pops up, the number of large mammals drastically decreases. And even we're talking large mammals here, like your elephants and whatnot. We're not talking dinosaurs. So even here, where in Africa the destruction is less, we still have bear in mind this is 1984. We still have, some giraffes, some elephants, etc. In these other continents, the number of large mammals is almost reduced to zero. And unfortunately, that is our own fault. Because we are doing this, often, as shown by this figure, after there has been a mass extinction event, there are gaps in the ecological niches that other species can then slowly over time evolve and fill in. So between the Paleozoic and the Mesozoic era, we've gone from having 6 types of megafauna down to 1. And that's because a organism that managed to survive this mass extinction, bridge this gap, was able to evolve and fill this ecological niche in the early Mesozoic era. And then over time, more organisms began to fill that empty ecological niche that was left by these 6 species of megafauna, producing the numbers of megafauna that we see by the late times of these geological periods. Because we continue to hunt and kill and change the planet, there is no time for these new ecological niches to become settled and allowing the surviving fauna and surviving animals to adapt and change and fill in that space. Because as this figure shows, let's say we got here in Australia, let's say we saw a giant kangaroo that was 30 feet tall. The first thing Homo sapiens are going to do is probably kill that thing, stuff it, and put it on somebody's wall. So that giant kangaroo never had time to reproduce and become a core part of that ecosystem. So that's one important reason as to why we have no megafauna here in 2024. Another important reason is energy. So this figure here from 2018 represents all of the biomass on planet Earth, and that's calculated by the percentage. It's the amount of the tons of carbon that are used in a biological manner. So you can see here that the majority of the biomass of planet Earth is from plants, but we're going to focus on this little grey triangle in the corner, which is the animals. And you can see here that the mammals, the wild mammals, the humans and the livestock make up this bottom corner down here. But what you're not seeing is the reptiles. Where are they? Well, they in 2024 make up an incredibly small amount of the global biomass. This is again due to those mass extinction events. You think of dinosaurs, you think of reptiles, right? So all of these reptiles were wiped out. It was the mammals that then rose up and began to fill those ecological niches left by all these dead reptiles. But being a warm-blooded creature, you need energy to maintain that constant internal body temperature. Obviously, cold-blooded creatures like your reptiles, they lie in the sun. They warm up through the energy of the sun to provide them with their energy to survive. Whereas us, the humans, the livestock, the wild mammals, we need to eat and consume in order to get our energy. And you can, just taking 2024 as a whole now, think of all the consuming that us humans do. Now imagine a single human that was 100 feet tall. How much consuming would he have to do? He'd have to eat vegetables by the farm load in order to maintain enough energy to be able to just survive. And planet Earth does not have that amount of fuel available to it. So mammals have evolved over time and filled their ecological niche where they are big enough to survive whatever it is they need to survive, but also small enough that their energy use is not so extreme. If we had infinite energy on planet Earth, maybe we would have some more megafauna, but unfortunately we do not. Again, talking about warm-blooded and cold-blooded, dinosaurs, you may think, oh, dinosaurs, they're reptiles, they must be cold-blooded, but actually data has shown that they may not have been cold-blooded. Some of them may have been, sure, but the majority of dinosaurs may have actually been warm-blooded, but were able to control their core body temperature and their rates of metabolism, allowing them to be much lower energy users than the mammals that we have today. And again, allowing them to, if they conserved more energy, if they used their energy more efficiently, they were able to grow to larger sizes. So when you think of a T-Rex maybe have been able to modulate its metabolic activity to use its energy more efficiently and grow to the sizes you think of when you think of dinosaurs. But the main reason, in my opinion, as to why we don't have megafauna these days is the cube-square law. So this is a depiction of the cube-square law, so apologies, we're going to get a little bit mathsy for a second, but worry not, it's not too complicated. So to describe it as basically as you can, the size of, as you increase the size of something, the surface area and the volume of that thing also increase, as you might imagine, right? The bigger something is, the more surface area it's going to have, and the greater the volume, how much space it takes up, is also going to increase. However, the surface area of something increases by the square of the size, whereas the volume increases by the cube of the size. So we can see here in a cube that's 1 by 1, the height is 1, the surface area of one face, which is added by this note here, and the mass of it, they're all 1, right? Because 1 squared and 1 cubed is also 1. But once we double the size of this cube into a cube that is 2 by 2, the surface area and the mass, so the mass and the volume are proportional to one another, are no longer identical to that of the height. So the surface area is now 4, 2 squared, and the mass, the volume, is now 8, 2 cubed. So you can see that as you increase the size of the organism, the gap between the surface area and the volume gets further and further apart. You know, by here, when we've got a 4 by 4 cube, the surface area of each side is 16, but the mass is 64. Strength and mass are proportional to the surface area and the volume. So you increase something by a particular size, the surface area will go up by a square, right? The strength of something is proportional to the cross-sectional area, and the mass of something is proportional to its volume. So much like the surface area and the volume seen in this figure here, the mass of something will soon outpace the strength of something as you increase the size. A simple way of thinking about this is through the legs of something. Right? You've got, I don't know, a little lizard, yeah, a gecko perhaps, and you double its size. So its surface area and therefore its strength has increased by a square, and the mass of that organism has increased by a cubed value. So a factor of 8 and a factor of 4 for the cubed and the squared specifically. So think of this cube here. You know, you then increase the size again, we're then entering this territory until eventually those little legs are not going to be able to support the mass of the rest of that gecko. So sure, you may have produced a 1,000-foot gecko or something, but this gecko is not going to be able to walk, and so there's therefore, you know, a reason why we don't have megafauna. But this goes far beyond just the legs, the blood vessels, the digestive tracts, airways. These are all limited by the area of a cross section and the volume that they take up, the mass of that thing. So all of these systems that keep us functioning all start to break down as size increases. Now I'm sure what you're thinking is, oh, but whales are big. Well, yes, this is true. Whales are big, but whales also live in water, and water exudes a lot of force on a lot of things. just think of it as if you ever tried to lift somebody up when they are submerged in water, it's considerably easier than trying to lift somebody up when they are just on terrestrial planet Earth. Think of it like that. The water has able to bolster the cube square law, say, allowing us to get some form of megafauna in the water. And now you're probably thinking, well, what about dinosaurs? Surely the laws of physics weren't that different millions of years ago. And you would also be correct. But we have to remember that most dinosaurs, or the ones that we can think of, are more related to birds than the humans that we have today. And birds have hollow bones, as shown by this figure here. And these bones fill up with air, allowing the overall weight of the bird to be not reduced, but bolstered by this extra air, allowing flight to take place. Dinosaurs had a similar bone structure with these hollow bones, and this allowed, as the dinosaur respirated and they filled up with air, the bones became filled with air, so the bones became overall lighter than if they were just a solid bone. This allowed the dinosaurs to be more motile because they were lighter, they were less dense, but also allowed the dinosaurs to reach greater heights in growth. So perhaps if we had hollow bones, maybe we would be able to reach larger sizes, but unfortunately we do not. And unfortunately the physics of the planet are not changing anytime soon, and I'm sure we won't stop destroying the planet at any rate. So I don't see any titans roaming the earth in our near future, but goodness do I hope I'm wrong. Thank you for listening.